lesson 6.4, which is dealing with triangle similarity, not to be confused with triangle congruency. Remember, congruent means that it's all the same. Similarity means it's not the same, but it's proportional. So I want you guys to remember, congruent means the same. Similarity means they're kind of the same, but they're not. They are just proportional, okay? So that's what it means in math. So let's go ahead and jump into some rules to help you to figure out triangle similarity. All right, so looking at my key points here, so it says angle, angle. That means if two angles of one triangle are congruent to two angles of another triangle, the triangles are automatically similar to each other. Not necessarily congruent, meaning they're similar, meaning proportional. So for instance, if I was to draw two triangles, so let's go ahead and just do this real quick so I can show you. So I'm going to draw two different triangles. So right now I have one triangle that's smaller and one triangle that's bigger. But in this instance, and I'm going to go ahead and name this triangle ABC. I'm going to name this DEF. Okay? So right now, if I have two triangles and two angles are congruent to each other. So let's go ahead and say angle A and angle D are congruent to each other. And let's say angle B and angle E are congruent to each other. So if I know two angles are congruent to each other, so that automatically means the third angle is congruent as well. But that means these are going to be similar to each other, which means everything is now proportional. All the angles would then be congruent, but the sides are going to be proportional to each other, meaning AB and DE are going to be proportional, BC and EF are now proportional, and AC and DF are proportional, meaning if I figured out the scale factor, I then could figure out all the other sides of the triangle as well. Okay, and we'll actually put that into play whenever I end up doing it with my examples down here. So again, if two angles of a triangle are congruent to two angles of the other one, they're automatically similar to each other. Same thing with side, side, side. But again, don't get it confused with congruence. If all three sides of a triangle are congruent, then they're congruent. But in this case, side, 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 I'm talking about proportionality. It says, if three sets of corresponding sides of two triangles are in proportion to the triangle, then that means the two triangles are similar. That means if I have two triangles, let's say I have this triangle and I have a bigger triangle. Let's say this side is 2, this side is 4. Let's say this side is 3, this side is 6. Let's say this side is 4 and this side is 8. Well, if you look, 2 to 4, 2 over 4, 3 to 6, 3 over 6, 4 to 8, 4 over 8. If I look, 2 is half of 4, so 1 half. 3 is half of 6, so 1 half. 4 is half of 8, so 1 half. So if you look, all three of those are going to be proportional to each other. So since all three sides of the triangle are proportional to each other, that means that the two triangles are similar. They're similar in detail, meaning they're proportional to each other. And then I could end up finding all three angles would then be congruent to each other because proportionality would then go with this as well, okay? So again, three sides are proportional to each other, meaning they are similar to each other, okay? Lastly, we're looking at side angle side. So it says, if an angle of one triangle is congruent and the two corresponding angles of another triangle and the length of the sides including these angles are proportional, then the sides are similar to each other. So that means if I have two triangles, so let's go ahead and just draw another one. I have two triangles. I have one angle that's congruent to each other, and then the two sides that make up that angle are proportional. So like if this was 2 and this was 4, and this was 4 and this was 8. 2 to 4, 2 over 4 would be 1 half. 4 to 8, 4 over 8 would be 1 half, so those are proportional. So if we have two sides that are proportional and two angles that are going to be congruent to each other, that means these two triangles are then similar, and we could find information to find those as well. So again, angle, angle, two angles, side, 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 all three sides are proportional. Side, angle, side, sides are proportional, but the angles are congruent. Then you can then prove that two triangles are similar, and then we can do some math later to find that, okay? Let's jump over to example number 1 to put this into play. All right, so looking at this example, it's saying, are the two triangles similar? If so, we need to write the similarity statement. So just so you guys know, a little squiggly line like this, that means similar. So if you see the little squiggly line, this means similar. So right there, that means similar, okay? So let's go and look at this. So right now, I just have all three measurements of both of these in the sides. So I'm trying to determine if these are going to be similar by looking at their proportionality. So if I go ahead and look, I'm going to go ahead and set up three different proportions to help me see this. So I have this is equal to this is equal to this. And what I'm going to do is I'm going to put the smaller triangle on top. I'm going to put the bigger triangle on bottom. So if I look, my smallest side of my small triangle is 6. So I'm going to put 6 here. My middle side on my smaller triangle is 8. And my largest side of my smaller triangle is going to be 9. And then I'm going to do the same thing with this triangle. My smallest side is going to end up being 12. My next smallest side is going to be 16. My next smallest side is going to be 18. So if I look, 6 is half of 12, so 1 half. 8 is half of 16, so 1 half. And 9 is half of 18. So since all three of those fractions are equal, meaning they're all proportional, that means that these two triangles are indeed similar to each other, okay? So let's go ahead and write my similarity statement. So I'm going to go ahead and do ABC. So triangle ABC. And remember, similar, I'm going to put my little squiggly line here. That means they are similar to each other, meaning the sides are proportional and the angles are congruent. So I had ABC. It looks like 12 and 18, so 6 and 9, so it's going to be D, E, F. So D, E, and F is going to be your sides that are going to be congruent to each other, okay? Let's look at example number 2. Okay, so looking at example number 2, it says, are the two triangles similar? If so, we need to write the similarity statement. Well, if I look, I don't have any sides that are congruent, so that means I can't use side angle side, I can't use side side side, so I don't know that, but I do have some angle measurements. So right now in this first triangle, I'm given 2 angles, but I know all 3 angles of a triangle are going to be congruent to each other. So right now, all 3 angles of a triangle add up to 180, they add up to 180. So right now, angle 21 and angle 105, those are going to add up to be 126. And if I wanted to find that third side, I'm going to subtract that from 180 degrees, right? So that'll give me 4. 17 minus 12 is going to end up giving me 54. So that means this angle right here is going to be 54. Well, whoa, let's go ahead and look. I have 21 degrees. I have 21 degrees. I have 54 degrees, I have 54 degrees. I have 2 angles that are congruent to each other. So ladies and gentlemen, I now know these 2 triangles are similar because of the angle-angle theorem, the angle-angle similarity theorem. So now I know that all the angles are going to be congruent and all of the sides are going to be proportional to each other. So right now let's go ahead and write my similarity statement. So now I'm just going to start out with writing the first one. So triangle ABC is going to be similar. Remember, squiggly line means similar. So triangle, it looks like angle A is going to be congruent to R. It looks like angle B is going to be congruent to Q. It looks like angle C is going to be congruent to P. So now, ladies and gentlemen, you have now created your similarity statement, which now means all the sides are proportional and all the angles are going to be congruent to each other. Let's jump over to example number 3. All right, so now in example number 3, it says, given the following information, we need to find the value of x. So right now, if you look, ABC, so ABC is going to be similar to GHK. So if I was actually looking for any of the angles, I know that all of these sides are going to end up, or all of the angles that line up to each other are going to be equal to each other. But I am looking at my side measurements here. So right now, since I know that these are going to be similar to each other, I know that all of the sides are proportional to each other. So let's go ahead and look. I have side BC here, which is 10, and BC is going to match up with HK and HK. So I don't know those 2 measurements, okay? So let's go and look at another line. So I have AC, which is 4, so A and C, which is 4. So A and C here is going to match up with G and K. Do I know what G and K is? Yes, I do. So I'm going to go ahead and just write that out. So I know AC over GK is going to end up being proportional to something else, or all of the sides are going to be proportional to each other. So AC, I know I'm multiplying times something to get to G to K, okay? So now let's go ahead and look. Now I need to find what X is. I can either use AB or HK. Let's go ahead and work with AB right now. So right now, if you look, A to B right now is going to be on the same triangle as AC. So I'm going to put AB on top. And now AB is going to be the same thing as GH because it's listed, AB and GH. So GH here is going to end up being here, which is going to be 20. So now I'm going to replace everything and then solve. So if I look, AC here, A to C is going to be 4. G to K here is going to be 10. AB here is going to be, AB is going to be X minus 3. And then GH here is going to end up being 20. So now if you look here, I can now cross multiply here to solve to make the two equal to each other, okay? So right now I'm going to do 4 times 20, which is going to end up giving me 80. And then I'm going to do 10 times X minus 3, so 10 times X minus 3, okay? So I'm going to distribute my 10, so I'm going to get 80 equals 10X minus 30. I'm going to add 30 on both sides, which is going to end up giving me 110. And I'm going to divide by 10 on both sides. So X is going to end up giving you 11. So if I plug 11 in there, that's going to end up giving me the value of X, which would then in return give me 8. Because if I look, 10 times 2 would give you 20. 4 times 2 would give you 8. So technically that would end up being 8. So X minus 3, add 3 on both sides, would end up giving you 11. So again, because I knew the two triangles are similar, I was able to use the proportionality of all the sides to end up solving for X here, okay? Again, guys, moving on to the challenge question. If you guys can look at the challenge question and you can work it on your own, meaning you don't need any help, that probably means you're ready to move on to the skill check. But if you're struggling with working the challenge question, call me over. I can help you out, try and figure out a couple of things that you're misunderstanding, and then you can move on to your skill check. But other than that, good luck with your skill check. Good luck with this lesson. Let me know if you need help.